In the early days of software, releasing a new version was a massive event. It happened once every 6 months, required a weekend of downtime, and involved a war room full of stressed engineers. But today, companies like Etsy, Amazon, and Netflix deploy code over 1,000 times every single day. How is this possible without the whole system collapsing? It isn't just about moving faster, it's about changing the very definition of a release. When you deploy 1,000 times a day, each change is microscopic. Instead of a giant leap, it's a series of tiny controlled steps. In this video, we are going to deconstruct the technical machinery and the cultural shifts required to achieve this level of velocity. We'll look at the pipelines, the safety nets, and the mindset that turns deployment from a scary event into a non-event. The first pillar of high-frequency deployment is the CI/CD pipeline. CI stands for continuous integration. In a high-velocity environment, developers don't work on feature branches for weeks. Instead, they merge their code into the main branch multiple times a day. Every time a developer pushes code, an automated system wakes up. It compiles the code, runs thousands of unit tests, and checks for security vulnerabilities. If a single test fails, the build is rejected instantly. This creates a fast feedback loop. The developer knows within minutes if their change broke something, while the context is still fresh in their mind. This shift-left approach to testing ensures that the main branch is always in a deployable state. You cannot reach 1,000 deploys if your main branch is constantly broken or unstable. But wait, how do you deploy 1,000 times without bothering the users? The secret is decoupling deployment from release. In a traditional model, these are the same thing. You push code and the user sees the feature. In a high-velocity model, we use feature flags. A feature flag is a simple conditional statement in the code. You can deploy the code for a new checkout button today, but keep it off for everyone. The code is live in production, but dormant. This allows engineers to test the code in the real production environment without any user impact. Once we are confident, we can flip the switch for 1% of users, then 10%, and eventually 100%. This is called a canary release. It turns a risky big bang launch into a controlled, observable rollout. To manage this volume, you need more than just scripts. You need an architecture that supports isolation. This is where microservices come in. If you have a massive monolith application, every deploy carries the risk of breaking the entire site. But if your application is split into 500 small services, a team working on the search service can deploy 50 times a day without ever touching the payment service. This isolation reduces the blast radius of any single failure. If a deploy goes wrong, only a tiny sliver of the application is affected. Combined with blue-green deployments, where we keep 2 identical production environments, we can switch traffic back to the stable version in milliseconds. High frequency is actually safer because the changes are smaller and the recovery is faster. You can't have a human being clicking approve 1,000 times a day. Automation is the engine. But how do you trust the automation? The answer is observability. Every deploy is monitored by automated health checks. The system looks at error rates, latency, and CPU usage. If it detects a spike in 500 errors immediately after a deploy, the system doesn't wait for a human to wake up. It triggers an automated rollback. This is the safety net that allows for speed. If you know the system will automatically undo a bad change in 30 seconds, you aren't afraid to deploy. We move from mean time between failures to mean time to recovery. We accept that failures will happen, but we build systems that heal themselves before anyone even notices. Finally, 1,000 deploys a day is a cultural achievement. It requires DevOps in its purest form. The people who write the code are the same people who operate it. There is no handover to an operations team. When a developer pushes code, they are responsible for its performance in production. This creates an environment of high accountability and shared ownership. It also requires a blameless culture. If a deploy breaks the site, the goal isn't to find someone to fire. It's to find the gap in the automated testing or the monitoring that allowed the failure to happen. We treat every failure as a free lesson on how to make the automation stronger. That is how you scale from 1 deploy a week to 1,000 deploys a day.